Light travels at 300,000 kilometers per second. That's the sentence you were given. But what if it isn't actually traveling at all? Here's what disturbs me. Light is the very tool you use to measure the universe. And the moment you ask what its motion actually is, the ground starts giving way. Right now, photons are hitting your eyes and assembling the world around you. But physics says those photons experience zero time crossing that distance. So did they travel? Or did they just appear? So let me show you what I mean. Not the comfortable version. The real one. Because once I walked through this, honestly, the world never looked quite the same to me again. The phrase is so smooth you almost never hear how much it assumes. Travel means something starts here, continues through a sequence of in-between positions, and later arrives there. A thrown baseball does that. A train does that. A bullet does that. Each one can, at least in principle, be imagined from its own side of the trip. Time passes for it. Distance is crossed. A path is inhabited. Light enters that sentence wearing the costume of an object. And that is where the trouble begins. You learned the number early. About 300,000 kilometers per second in vacuum. Vacuum just means empty space, stripped as clean as nature allows. The number is so large that it creates awe automatically, which is convenient, because awe often hides confusion. Call something unimaginably fast, and most people stop asking whether fast is even the correct category. But speed is not just admiration with mathematics attached. Speed is distance divided by time. It belongs to things that occupy successive places while time passes for them. That seems harmless until you ask a question simple enough to sound childish. What exactly is doing the moving here? Take a flashlight into a dark field at night. Click it on. A pale cone opens in front of you. Dust flashes. The beam strikes a fence post 20 meters away. Everything in the scene tells your nervous system that something has gone from your hand to the wood. The mind is almost helpless in this situation. It wants a traveler. It wants a little procession from source to target. Now slow the scene down in thought. Imagine freezing the field into a sequence of impossible still frames. In one, the bulb has just emitted light. In the next, the beam extends halfway. In the next, it touches the fence. Your intuition fills the gap with a moving thing, as though reality were a flipbook and light were the runner crossing each page. But physics does not reward that picture for very long. This is where I need to state the rule clearly before breaking it. Ordinary motion assumes you can always ask what the moving thing is doing from its own frame of reference. A frame of reference is just a viewpoint tied to some state of motion. Your car, your chair, a drifting spacecraft. It is the local perspective from which you measure distance and time. For ordinary objects, that question works beautifully. For light, the question does not merely get difficult. It starts to become illegal. That should bother you more than it probably does, because the sentence light moves sounds as innocent as rain falls. Yet one of those belongs to ordinary experience, and the other turns out to sit on top of a structural exception built deep into reality. Light is not just another thing rushing around inside the universe. Physics keeps forcing it into a stranger role, as though the world were built around its behavior rather than merely containing it. You can feel the tension even before the equations arrive. If you run toward a train, its speed relative to you changes. If you walk away from a thrown ball, its speed relative to you changes. That is how motion behaves in ordinary life. Relative just means measured compared with something else. Different observers moving differently get different speeds. Simple, clean, familiar. So the obvious expectation is that the same should happen for light, and yet it does not. You can move toward a beam, away from it, sideways to it, launch detectors from aircraft, satellites, or planets, and the structure of modern physics is built around the same stubborn fact. The speed of light in vacuum does not adjust itself the way every ordinary intuition says it should. This is not a tiny correction. It is not a weird laboratory footnote. It is one of the load-bearing facts of reality. That alone would be enough to make light special. But the deeper problem is subtler. The specialness is not just numerical. It is conceptual. The universe seems willing to let you compare your motion with trains, bullets, dust, planets, and blood cells. But when you try to extend that same mental habit to light, the framework begins to tear. Think about sunlight on your skin. The photons reaching your hand left the sun roughly 8 minutes ago. That statement is perfectly usable. It lets engineers build instruments, astronomers time events, and ordinary people understand delay. But now, press harder. What does that interval mean for the light itself? What is the shape of that crossing from the light side? That is the point where language starts smiling nervously, because from the light side sounds like a reasonable phrase only if light can possess the kind of perspective that ordinary moving things possess. You assume there is a journey that the photon undergoes, a duration it somehow lives through, a before and after that belong to it as it belongs to the trip. The deeper you go into relativity, the less stable that assumption becomes. Not just false in detail, false in form. I find this beautiful in the same way I find a crack in a foundation beautiful. Not pleasant. Not reassuring. Just revealing. The first time you really accept that the visible world depends on something that may not fit the everyday idea of motion, a lot of comfortable sentences begin to wobble at once. Light travels. Light leaves. Light arrives. These remain useful, but usefulness is not innocence. A map can guide you perfectly and still hide the terrain that matters most. And light may be the greatest example of that in all of physics, because once you stop treating it as merely the fastest moving thing, a more dangerous possibility appears. Maybe light is not strange because it moves in an extreme way. Maybe it is strange because motion itself, the ordinary common-sense version you built from cars and stones and footsteps, was never deep enough to contain it. That is where the real trouble begins. The rule is simple enough to feel almost beneath notice. If something moves, then in principle you can move along with it. You can imagine matching its speed, sitting beside it, and describing the trip from its side. That rule works for dust in a sunbeam, for a thrown knife, for a planet, for a drifting atom. It works so well that you mistake it for a property of reality itself, rather than a habit formed inside slow human life. Light is where the habit breaks. Suppose it did not. Suppose light were normal in exactly the way your instincts want. Then you could chase a beam the way a child chases a bicycle. Run fast enough, and the light in front of you would seem to slow down. Match its speed exactly, and the wave would freeze into place like ripples locked on glass. You would be staring at a motionless pattern of electric and magnetic structure, held open in front of your face like a luminous sculpture. Physics does not allow that picture to survive. That frozen wave image is not merely unobserved. It collides with the deeper structure of electromagnetism. Electromagnetism is the theory describing electricity, magnetism, and light as one connected system. In plain language, it says changing electric fields produce magnetic fields, changing magnetic fields produce electric fields, and the mutual regeneration propagates outward as light. The entire mechanism is built on change. A frozen light wave would not be a beam paused mid-journey. It would be a contradiction. That matters because it tells you something severe. The ordinary strategy for understanding motion, go with the moving thing, fails at exactly the point where light begins. You can feel the trap from another angle. Take a train moving at steady speed and shine a flashlight from the front car. A passenger sees the beam race away at light speed. On the embankment, you expect a different answer because the train itself is already moving. Common sense wants the outside observer to add the train speed to the beam speed, the way you add walking speed to a moving walkway. That is how almost everything else behaves. Throw a ball forward on a train, and the ground observer measures the train's speed plus the throw. Launch a drone from a truck, and the road observer combines both motions. Stack motion on motion. Add velocity to velocity. The rule is so universal in daily life that you stop seeing it as a rule at all. Then light refuses the addition. This is the point where people often think physics has become mystical. It has not. It has become less obedient to human intuition. The measurements do not say light is sort of special, or special under rare conditions. They say the old bookkeeping system for motion is wrong at the level where space and time themselves have to keep the accounts. That sentence is easy to hear too quickly, so slow it down. Not the object, the bookkeeping. When speeds are small, your mind treats time as a shared background, and space as a neutral stage. Motion happens inside those containers. One observer adds a bit, another subtracts a bit, and everyone agrees on the clock underneath. Light is the phenomenon that exposes the price of that assumption. To preserve its measured speed, the universe does not let light bend to your old kinematics. Kinematics just means the geometry of motion, who moved, how far, and for how long. Instead, it makes space and time absorb the strain. That is the reality check. The contradiction is no longer light is very fast. The contradiction is that the world will reorganize time before it lets light become ordinary. And once you grasp that, the category error comes into view. You have been trying to imagine light as a traveler inside time, when part of the evidence suggests it is bound up with the structure that defines time relations in the first place. Here is the consequence sketch that should make you uneasy. If light behaved normally, then different observers could disagree about its speed the way they disagree about a passing car. If that happened, Maxwell's equations, the mathematical rules governing electromagnetic fields, would not hold in the same form for everyone. The laws of physics would become observer fragile. Reality would have no stable causal speed limit. The universe would be locally negotiable in a way it plainly is not. So something had to give. It was not light. It was your old picture of motion. And this is only one item on a longer list. Because once the fastest thing in the universe stops behaving like a thing that can be accompanied, a more dangerous question appears behind it. What would a trip even mean if the traveler cannot be assigned an ordinary point of view? The ordinary rule is mercilessly clear. If something goes from here to there, then there is a there between. A traveler occupies intermediate positions. It undergoes duration. It has, so to speak, an interior history of the crossing. You may not know every detail, but the trip itself belongs to the thing that makes it. That is what makes light so corrosive to intuition. Say it in the most familiar form possible. Sunlight reaches Earth in about 8 minutes and 20 seconds. That sentence is operationally true. You can use it to calculate solar delay, spacecraft timing, and the lag between an event on the Sun and its visible arrival here. But the sentence quietly smuggles in a human picture. Something left, remained in transit for a while, then arrived. The deeper you push on that picture, the less secure it becomes. Stand outside at dawn. The eastern sky is paling. A cold rim of light appears along a rooftop, then slides down the wall, brick by brick. The scene feels full of travel. It feels as though a radiant substance has crossed 93 million miles of emptiness and is now finally pouring into the street where you stand. Your whole visual system endorses the narrative. The journey seems almost tactile. Now separate two things your senses have fused together: the measured interval and the lived interval. The measured interval belongs to observers like us, embedded in clocks, planets, and rotating frames. Measured just means assigned by some physical process we trust to mark duration. A quartz oscillator, an atomic clock, the swing of a pendulum in older worlds. From our side, light takes time. It leaves the sun, and minutes later it reaches your skin. But from our side is the phrase doing all the labor. Because the moment you try to ask what that duration means for the light itself, you step onto unstable ground. In relativity, a proper time is the time measured along an object's own path. Plainly put, it is the duration a traveler carries with it, the internal clock of the trip. For ordinary things, that is one of the most natural ideas in physics. Your heartbeat, your aging, your coffee cooling in your hand, these unfold along your path through space-time. Space-time just means space and time treated together as one structure rather than two separate containers. And light appears to sit at a limit where that internal duration collapses. I need to be careful here, because this is one of those places where popular language becomes sloppy very quickly. Physicists do not say a photon has a normal point of view and then describe what it experiences. In fact, that move is exactly what the theory resists. We do not assign a valid rest frame to light, a rest frame being the viewpoint in which something is stationary, because the machinery of relativity does not extend there in the ordinary way. That is not a small technical caution. It is the center of the disturbance. If light were normal, the story would be easy. A photon would leave the sun, carry its own little thread of duration, drift through space, and after 8 minutes of its own continued existence, collide with your eye. The phrase "the trip from the photon's side" would be meaningful in the same way the flight from the bird's side is meaningful. You could ask what changed for it along the way. You could talk about its passage as a lived sequence. Instead, the equations point towards something harsher. Along a light-like path, meaning a path taken by light through space-time. The proper time is zero. Zero is a dangerous word here. It does not mean we secretly know what the photon feels, and it feels instantaneous. It means the mathematical structure assigns no ordinary traveler duration to the path at all. That is a very different claim. The best metaphor I know is a corridor that exists for everyone in the building except the messenger who defines its length. Imagine a palace with rooms connected by hallways. Every servant, guard, and guest must spend time crossing those halls. Their shoes strike the floor, their breathing continues, their candles burn shorter. But the royal seal, carried as a legal instruction from one chamber to another, is not part of that ordinary procession. The architecture is partly defined around its valid transmission. Its journey organizes the house, yet it does not belong to the house in the same way the walkers do. The metaphor is imperfect, but I keep returning to it. Light behaves less like a passenger inside space-time than like a boundary condition woven into its structure. That perspective resolves one earlier anomaly at once. It explains why the old fantasy of riding alongside a beam fails so badly. The fantasy assumes light is the kind of thing that can host an accompanying viewpoint. But if the path itself carries no ordinary internal duration, then the whole image of a companionable trip was wrong from the beginning. You were asking for the wrong kind of insight. And still, I need to say this plainly. This does not mean we have converted light into something fully intuitive. We have only made the contradiction sharper. because now you are left with a stranger picture. Light undeniably links events. Emission here, absorption there, cause at one location, effect at another. Instruments detect the interval. Equations track the propagation. And yet the familiar human grammar of what happened during the trip for the traveler begins to dissolve the moment the traveler is light. That should change how you hear basic sentences. The light from a distant galaxy reaches your telescope after millions of years. True, from our clocks. The flash from a supernova crosses space and enters a detector long after the star has died. True, from our clocks. Your room brightens a fraction of a second after you switch on a lamp. Again, true from your clocks. Your wiring, your apparatus, your frame. The between is real, but not in the ordinary biographical sense you keep trying to impose on it. And once you see that, a worse question begins to form. Maybe light is not merely moving through the universe in an unusual way. Maybe it is helping define what counts as separated, connected, and causally reachable in the first place. But this is only one item on a longer list. If light connects distant events without ordinary experienced passage, then what kind of between does it inhabit? The usual assumption is that the universe is a container, and motion happens inside it. Space is the stage. Time is the clock on the wall. Objects enter, move, collide, leave. Light, in that picture, is simply one actor with unusually dramatic speed. Relativity forces a colder conclusion. Light is not merely performing inside the stage. The stage itself seems built around the fact that light behaves the way it does. You can see the shift with one physical image. Stand in an open field during a thunderstorm. Far away, lightning branches across the clouds. A few seconds later, thunder reaches you. No one finds that mysterious. Light arrives first because light is vastly faster than sound. Sound here is ordinary, a pressure wave in air, dependent on a medium, slowed by matter, easy to outrun in principle if you had absurd machinery. But now remove the atmosphere, remove the air, remove the storm. Imagine instead two events in empty space. A star flares, and years later a detector registers the flash. What links those events is no longer just a fast signal, it is the maximum structure of causality itself. Causality is a severe word for a simple fact. Which events can influence which other events? What can reach what? What can matter somewhere else before it is too late? Light does not merely travel through that network. It draws the boundary lines. The cleanest place to begin is with an event. In relativity, an event is not a whole process or a long story. It is one precise happening at one place and one time. A bulb flashes, a particle decays, your finger presses a switch. Physics builds upward from these points. That sounds dry until you notice what happens next. Once you have an event, the universe sorts all other events around it into three families. First, events that can be affected by it if a signal leaves at light speed or slower. That means influence is possible. Second, events that could have affected it if a signal had enough time to arrive. That means explanation is possible. Third, events too far away in space and too close in time for any signal, even light, to connect them. That means no causal bridge exists. That sorting is not philosophical decoration. It is geometry. Geometry here does not mean triangles on paper. It means the shape of possibility in space-time. You can picture it as a great double cone centered on one event, one cone opening into the future, one into the past. These are called light cones. A light cone is the set of all places a light signal can reach from an event, or from which it could have arrived. In plain language, it marks the edge of what can matter. That edge is not arbitrary. It is not chosen by convenience, or biology, or measurement technique. Nature seems to have welded the structure of influence to the behavior of light. Imagine a dark planet with no atmosphere and no horizon glow. On a plain of black rock, a beacon flashes once. Draw all the destinations that flash could reach after 1 second. You do not get a vague cloud. You get a sharply expanding sphere of possible influence, moving outward at light speed. After 2 seconds, the sphere is larger. After 3, larger still. Stack those spheres through time, and the geometry becomes a cone of reachability. That is what light is doing at the deepest level. It is not just illuminating objects. It is tracing the frontier between connected and disconnected events. This resolves one of the earlier tensions immediately. We kept asking what the between is for light, if the normal traveler picture fails. The answer is harsher and better. The between is not primarily a biography of the photon. It is a geometric relation between events in space-time. Light is special because its paths sit exactly on the boundary between what can be causally linked and what cannot. And yet this explanation is still incomplete. It tells you why light has structural importance. It does not yet tell you what light fundamentally is. That deeper question is still waiting. Now the metaphor I find hardest to shake. Light is less like a runner on a road than like the edge of a jurisdiction. Imagine a vast empire, where every messenger, soldier, and wagon moves under legal limits. There is a final line beyond which no order can have arrived yet. Inside that line, authority may already operate. Outside it, events remain untouched. Light behaves like that frontier. It is not merely one more citizen of the kingdom. It is the boundary that tells you where the kingdom's influence currently ends. Once you think that way, several earlier confusions stop being confusions. Why can you not assign light an ordinary rest frame? Because the geometry is not treating light as a normal occupant of the interior. Why does the speed of light refuse to behave like train speeds or thrown balls? Because the limit is not accidental. It is load-bearing. Why did the old image of riding alongside a beam fail? Because you were trying to stand on the border as though it were an ordinary region. Now push one step farther. If light were normal, then causality would blur. Different observers could redraw the frontier differently in a loose, additive way. One person's impossible influence could become another person's allowed signal. The architecture of cause and effect would wobble. Physics would stop being one world seen from many perspectives and become many incompatible worlds stitched badly together. That is not the universe we inhabit. Instead, observers in relative motion may disagree about distances, durations, and even simultaneity later on, and that problem is coming. But they do not get to negotiate the causal role of light away. The cone remains the cone. The boundary remains the boundary. The geometry protects the law before it protects your intuition. You live inside this structure constantly without noticing. Every message on your phone, every star you see, every face across a room, every surgical laser, every radio transmission, every delayed glimmer from the moon, all of it is happening under one strict territorial rule. Light does not merely move through your world. It defines which parts of your world can be in conversation at all. And that is already stranger than the schoolbook version. Because the moment a phenomenon becomes the border of causality, it stops being just another physical object. It becomes part of the grammar of reality. That does not make it supernatural. It makes it more severe, more structural, harder to picture, and harder to dismiss. But the geometry creates a new pressure. If reality is organized around a limit that mass can never share, then light is no longer just special. It is foundational in a way that threatens the ordinary idea of time itself. Why would reality be organized around a limit that nothing with mass can ever share? The old rule was comforting. Everyone may disagree about motion, but they still share one common time underneath. You can argue about who is moving fastest, who is standing still, who passed whom on the road. But surely the clocks remain innocent. Surely now stays universal. Even if positions shift, light is where that innocence ends. Imagine a long train moving smoothly through the night. In the exact middle sits a passenger with a detector. Lightning strikes both ends of the train at what the passenger judges to be the same moment. Two flashes race inward. They reach the detector together. For the passenger, simultaneity looks obvious. Simultaneity just means two events happening at the same time. Now stand on the embankment as the train moves past you. From your viewpoint, the middle of the train is moving toward one flash and away from the other. If light speed is the same for you and for the passenger, then the flash the detector moves toward cannot have started later and still arrived together. The symmetry has broken. The conclusion is brutal. Events that were simultaneous for the passenger are not simultaneous for you. That is not an optical illusion. It is not bad bookkeeping. It is one of the prices the universe pays to keep light structurally fixed. This is the point where many people think relativity says everything is subjective. It says almost the opposite. It says the underlying laws are objective enough that your private intuition about shared time must be sacrificed. The disagreement is not chaos. It is disciplined disagreement, governed by exact transformation rules linking one frame to another. A transformation here just means a lawful conversion between different observers' measurements. You can now see the pattern accumulating. Light speed remains fixed. Consequence, simultaneity breaks. Cause and effect stay protected. Consequence, not every disagreement is allowed. Massive objects remain below light speed. Consequence, some paths through space-time are open to you, and some are forbidden. This is no longer a story about one strange beam. It is a redesign of temporal reality. The next fracture is duration itself. Consider a light clock, one of the cleanest thought experiments in physics. Picture two mirrors facing each other inside a spacecraft, with a pulse of light bouncing straight up and down between them. Each round trip marks one tick. Simple, mechanical, almost toy-like. For the astronaut riding beside it, the pulse takes the shortest path. Straight up, straight down. For you, watching the craft streak past, that same pulse traces a diagonal zigzag because the whole apparatus moves sideways while the light travels. The path is longer, but the speed of light is still the speed of light. If the speed stays fixed and the path gets longer, the tick must take more time. There is no spare option left. Time dilation enters here. Time dilation means a moving clock ticks more slowly relative to another observer's frame. Plain language, motion through spacetime changes how duration is apportioned. The more the geometry bends around light's fixed roll, the less different clocks can agree without qualification. That sounds abstract until you make it physical. A particle created high in Earth's atmosphere should decay before reaching the ground. A decay is simply a transformation from one particle state to another, often very quickly, and yet certain muons, short-lived particles born in cosmic ray collisions, survive long enough to be detected at Earth's surface in large numbers. From our frame, their internal processes are slowed by high-speed motion. From their frame, the atmosphere's thickness is contracted. Different descriptions, same outcome. The particle lives through a world with rewritten time. So do we, only more gently. Here is the catalog that matters. Moving clocks drift. Consequence: duration is not universal. Fast travelers age less between meetings. Consequence: reunion is no longer temporally symmetrical. Distances contract along motion. Consequence: space itself participates in preserving light's role. Simultaneity fractures across frames. Consequence: the meaning of at the same moment becomes local, not cosmic. Causal order stays protected where it must. Consequence: relativity is not permission for nonsense. You can feel the architecture now. Light is not merely the fastest messenger allowed by physics. It is the constraint that forces clocks, rulers, and event order to stop pretending they were absolute. I keep coming back to the image of a legal system so rigid that it would rather redraw every city map than let one forbidden crossing become valid. That is what relativity feels like. You try to smuggle an ordinary intuition across the border. Shared time, additive speed, universal now, and the universe confiscates it. Not angrily, cleanly. This also resolves a pressure that has been building since the beginning. We asked why light could not be treated as an ordinary traveler with an ordinary internal narrative. The answer is no longer merely that light is unusual. The answer is that time itself is being reshaped to maintain the geometry in which light occupies the boundary of causality. Once you see that, light stops looking like a thing inside the system and starts looking like part of the system's operating logic. And still, a deeper unease remains. Because relativity tells you what the world must do if light speed is invariant. Invariant meaning unchanged across inertial frames, across observers moving steadily relative to one another. It tells you how clocks behave, how distances distort, how causes remain fenced from impossible effects. It gives you the rules with astonishing success. GPS systems would fail without these corrections. Particle accelerators would make nonsense without them. The mathematics is not fragile. But mathematics that works is not always the same as understanding that settles the mind. You now know why time bends around light. You know why simultaneity fails. You know why your everyday model of motion was provincial. Yet a harder question has survived every answer so far. If light defines the structure of time itself, is it even one phenomenon among others anymore? The ordinary rule is brutal in its simplicity. Objects live inside laws that already exist. A stone falls within gravity. Smoke drifts within air. A planet moves within space-time. You can describe each one as a resident of a larger system, not as something the system is secretly built around. Light keeps refusing that rank. By now the pattern is impossible to miss. Its speed is not negotiable the way ordinary speeds are. Its paths mark the edge of causal reach. Its existence forces clocks to diverge, lengths to shrink, simultaneity to fracture. Those are not decorative oddities. They are structural concessions made by the universe itself. When one phenomenon compels space and time to recalculate rather than behave normally, you are no longer looking at an ordinary object with unusual performance. You are looking at something closer to a rule. Take a concrete scene. A hospital room. A patient lies inside an MRI machine sealed in white geometry, listening to the machine hammer and whine. Elsewhere, a GPS satellite is moving above Earth, carrying clocks that must be corrected for relativity, or your map would drift. In another place, a radio telescope catches photons that began their journey before human civilization existed. These events feel unrelated. Medicine, navigation, astronomy. But they are held together by one severe fact: the universe does not permit light to become provincial. Provincial is the right word here. Your everyday intuitions were built in a tiny speed range, inside weak gravity, on a warm planet, among objects that move slowly compared with light. Under those conditions, space seems fixed and time seems shared. The fact that this local common sense fails under deeper scrutiny is not embarrassing. It is revealing. You were never seeing the operating system. You were seeing a user-friendly interface. And light is one of the places where the interface cracks. Here is the catalog that sharpens the point. Matter gains energy and resists acceleration as its speed rises. Consequence: mass-bearing things are fenced away from the light boundary. Signals slower than light live inside the cones of causality. Consequence: they remain subordinate to a geometry they do not define. Clocks and rulers deform to preserve light's invariant role. Consequence: measurement tools are being adjusted around light, not the other way around. The vacuum itself supports electromagnetic propagation. Consequence: light is not borrowing a medium like sound borrows air. Each item points in the same direction. Light is not being treated as one citizen among many. It is acting more like the conversion rate between the currency of space and the currency of time. That metaphor matters, so let me stay with it. Imagine a nation with 2 languages spoken across every province. Every contract, every law, every border crossing depends on one fixed exchange table between them. Merchants may argue over price. Travelers may disagree over routes. Local customs may vary wildly. But the one thing the state cannot afford to let fluctuate freely is the conversion rule itself, because the entire legal order depends on it. In relativity, light speed plays something like that role. It is not just a fast phenomenon moving through the territory. It is part of the hidden exchange law by which spatial separation and temporal separation are traded into one another. That is why equations keep elevating it. You can see the same pressure in massless particles. Massless means having no rest mass, no intrinsic mass possessed while stationary, which already sounds odd because light is not allowed the ordinary stationarity that would make the phrase emotionally intuitive. A massless thing in relativity does not merely happen to move fast. It must move at light speed in vacuum. Not prefers. Must. The structure leaves no middle setting. If light were ordinary, there should have been one. There should have been slow photons, parked photons, drifting photons with adjustable speeds depending on who emitted them or how violently they were launched. Nature could have offered a spectrum of possibilities, as it does for stones, bullets, air molecules, and planets. Instead, it draws a line and places light exactly on it. That is not how the universe treats furniture. That is how it treats architecture. This resolves something important from the earlier parts. We kept circling the failure of the traveler model, and the impossibility of assigning light an ordinary companionable viewpoint. The reason now looks less mysterious and more severe. Traveler language belongs to inhabitants of the space-time interior, to entities that move through allowed regions under shared geometric rules. Light keeps appearing not as a comfortable inhabitant of that interior, but as a phenomenon pinned to its limiting structure. Still, I need to say what this does not yet explain. It does not tell us what light is in the deepest ontological sense. Ontological is one of those words people use when they mean the bare question of what something is, beneath measurement, convenience, and mathematical performance. We do not know how to translate all of light's roles into one humanly satisfying picture. We know a great deal about how to calculate it, generate it, detect it, quantize it, and exploit it. But a stable mental image that survives both relativity and quantum theory remains elusive. That is not failure, it is pressure. Stand in a room at night and switch on a lamp. The wall glows. A glass of water catches a pale stripe. Your hand rises and becomes visible to you. Nothing in that scene feels like metaphysics. It feels domestic, harmless. But buried in that instant is a fact that should change the emotional temperature of the room. Visibility itself depends on something the universe treats less like an object, and more like a limit, a law, a border condition. That is already too strange to fit inside schoolbook language, and it forces the next step. Relativity has told us what light does to the world. It has shown us the privileges the universe grants it, and the sacrifices imposed on time and space to preserve those privileges. But that still leaves the core question suspended in front of us, untouched and necessary. Relativity tells us what light does to the world, but what is light in the first place? The bullet picture fails first because it is too small. A bullet is a compact thing with an edge, a location, and a path you can imagine independently of the space around it. It leaves a gun, crosses air, strikes a wall. Even when it spins or deforms, you are still dealing with one localized object moving through a background that remains mostly passive. That image is so deeply wired into human thought that we keep trying to upgrade it rather than abandon it. So we imagine light as a finer bullet, smaller, faster, more pure. That instinct explains almost nothing. Start from the simplest correction. Light is an electromagnetic wave. That phrase can sound like a textbook label, so strip it down immediately. Electromagnetic means involving electric and magnetic fields. A field is not a little object hiding somewhere. It is a value spread through space, telling you what is possible at each location. Temperature over a room is a crude analogy. Wind over a landscape is another. The important point is that a field is not a bead traveling through emptiness. It is a distributed condition of the region itself. This is where the conceptual floor changes beneath you. Rub a balloon on fabric and hold it near your arm. The hairs rise. Bring a magnet near iron filings. They rearrange into visible arcs. In both cases, nothing like a tiny pellet had to fly from one object into the space between. The space was already structured. Forces became visible because the field was there to begin with, shaping what could happen locally. Light belongs to that family, not to the bullet family. Now make the scene more exact. Imagine an electron in an antenna being shaken back and forth by an oscillating current. Oscillating just means repeatedly moving one way, then the other, in a regular pattern. A changing electric field forms around that motion, but a changing electric field does not stay self-contained. It generates a changing magnetic field. That changing magnetic field then generates a changing electric field farther out. The disturbance propagates. That word matters. Propagates does not mean a little nugget runs forward. It means the pattern recreates itself from place to place according to local rules. The best metaphor here is not a projectile. It is a debt chain in a tightly linked financial network. One bank fails to settle an obligation. That missed payment changes the state of the next bank, which changes the next, which changes the next. Nothing like a physical coin has to race intact through every institution for the effect to spread. The disturbance is transmitted because each location updates in response to its neighbor. The pattern moves because the conditions compel successive local changes. Electromagnetic propagation works more like that than like a fired pellet. Or use a more physical image. Picture a stadium wave. No single ribbon of matter runs around the arena carrying the shape. The people stay roughly where they are. The pattern advances because each row responds to the row beside it. Light is not identical to that, but it is closer in spirit than the bullet picture ever was. What travels is a structured disturbance of the field, and this resolves an earlier anomaly immediately. We kept running into trouble whenever we tried to imagine light as a normal traveler with an ordinary internal journey. The field picture weakens that trap. It shifts the focus away from a tiny object undergoing a trip and toward a lawful propagation across space-time. The between is no longer primarily a biography. It is the spread of a field disturbance. That is a better framework. Not complete. Better. You can see why it was needed. The bullet picture cannot explain interference cleanly. Interference is what happens when waves overlap and their effects combine, sometimes reinforcing, sometimes canceling. In plain language, two beams can produce brightness here and darkness there, simply because their oscillations line up differently. That is natural for wave behavior. It is conceptually ugly for hard pellets. The field picture also handles polarization more honestly. Polarization means the orientation of the wave's oscillation. Light can be filtered according to that orientation, which is why polarized sunglasses reduce glare. A bullet does not naturally come with that kind of distributed directional structure across space. A field wave does. And there is another gain. The old image made empty space feel inert, like a dead corridor through which light had to be launched. The field picture says the corridor is not dead at all. Space can host electromagnetic structure. It can sustain changing electric and magnetic values linked by Maxwell's equations, the equations that unify electricity, magnetism, and light into one system. That is why vacuum is not nothing in the naive sense. It is not filled with air or ether, but it is not a blank absence either. It is a stage with lawful capacity. That phrase deserves caution. Stage with lawful capacity is not a mystical claim. It just means empty space is not forbidden from having field values and changes. Still, do not let the new clarity seduce you too quickly. A field picture is stronger than a bullet picture, but it is not yet the whole truth. It tells you why light need not be imagined as a tiny glowing marble crossing darkness. It explains why propagation can be local, lawful, and structurally tied to space-time itself. It helps with interference, polarization, and the failure of ordinary traveler language. But it also opens a new wound, because if light is a wave in the electromagnetic field, then you immediately want to ask, a wave of what, exactly? In water, the answer is obvious. The water itself oscillates. In air, sound is carried by pressure changes in the gas. But electromagnetic waves do not require a material medium in that old mechanical sense. The field is not a substance you can scoop into a bucket. It is more abstract and more fundamental than that. We describe it with extraordinary precision. We use it to build civilization. Yet when intuition asks what is literally waving, the answer becomes thinner than most people expect. So the bullet had to die. It was too crude to survive the evidence. But the replacement is not emotionally comfortable. You now have a cleaner picture and a stranger one. Light is better understood as a propagating structure in a field, not as a tiny object sprinting through blackness. But the moment you accept that, another problem appears almost immediately. A field story is better. But can it really explain why light behaves both continuously and discretely? The field picture survives much longer than the bullet picture. But eventually it runs into a harder fact. Light does not merely spread. It also arrives in packets. That is where the disturbance begins. The old rule for waves is familiar. A wave is divisible. Half the water wave is still a wave. Turn down the speaker, and the sound becomes weaker by smooth degrees. If light were only a classical field wave, classical meaning non-quantum, continuous, infinitely splittable in principle, then dimmer light should simply deliver less energy in an endlessly smooth way. Experiments do not let that happen. Take a sheet of metal under ultraviolet light. Electrons are ejected from the surface. This is the photoelectric effect, one of the key fractures that forced 20th century physics into the quantum era. In plain language, light can knock electrons loose from matter, but it does so with a threshold behavior that refuses the old smooth wave story. Increase the brightness below a certain frequency, and nothing happens. Raise the frequency enough, and electrons appear immediately. Not eventually, not after the wave builds up enough force. Immediately. That detail is the knife. If light were only a spread-out classical sloshing of energy, then sufficiently intense low-frequency light should, in principle, accumulate enough effect over time to kick electrons out. It does not. The metal behaves as though light arrives in discrete transactions. Discrete means separated into countable units rather than smeared into a perfectly continuous flow. The unit got a name, the photon. This is where language becomes dangerous again. The word photon tempts the mind back toward the bullet. Tiny bead, tiny dart, tiny glowing grain. But that is not what quantum theory licenses you to imagine with confidence. A photon is better described as a quantum of the electromagnetic field. A minimal excitation, a countable packet associated with the field's behavior. Excitation here means the field is not in its lowest possible state. Something real and transferable has been added. So the field did not disappear. It became stranger. Picture a piano keyboard extending beyond sight in both directions. The field is not one note ringing through the air like a moving marble. It is the entire instrument, the structured possibility of vibration across the system. A photon is not a pebble tossed across the keyboard. It is more like one quantized activation of a mode the instrument allows. The metaphor is imperfect but useful. It shifts you away from tiny object thinking and toward lawful excitations in a deeper mediumless structure. And yes, that word mode matters. A mode is simply an allowed pattern of oscillation. Physics often advances by discovering that what looked like a thing moving is better understood as a pattern the system permits. This helps resolve the pressure left hanging at the end of the last part. We asked how light could behave both continuously and discretely. The answer is that the field is continuous in its structure and evolution. While exchanges of energy with matter occur in quantized units, that does not collapse the mystery, but it removes one false contradiction. The continuity belongs to the field description. The discreteness appears in how the field can be excited and how those excitations are emitted or absorbed. Better. Still not comfortable. Now place yourself in a dark laboratory. A source is turned down so low that photons strike a detector one by one. Tiny clicks accumulate. Each event looks local, punctate, countable. One hit, then another, then another. It is very hard not to think in pellets at that moment. But if you route the same experiment through a double-slit setup, the pattern that accumulates over time still forms an interference distribution, the same hallmark of wave behavior we discussed earlier, one by one, yet wave-like in aggregate. That is not a poetic paradox. It is the quantitative behavior of light. Here the catalog matters. Light interferes. Consequence, pure pellet language fails. Light is absorbed in discrete energy packets. Consequence, pure continuous wave language fails. Light produces localized detector events. Consequence, the effect does not look like a uniform smear. Light is described by a quantized field. Consequence, wave versus particle. was already the wrong courtroom. That last point is worth saying more sharply. The phrase wave-particle duality was historically useful, but it can now mislead. It sounds as though light is two old familiar things awkwardly glued together. Sometimes wave, sometimes particle. Costume change by context. That is not the deepest lesson. The deeper lesson is that both classical categories are approximations, and quantum field theory replaces them with something less intuitive but more faithful. Quantum field theory is the framework in which fields are fundamental, and particles appear as quantized excitations of those fields. I need to say this explicitly: we do not know how to turn that framework into a perfectly satisfying everyday picture. We know how to calculate with extraordinary success. We know how to predict scattering outcomes, energy transfers, detector statistics, and radiative processes with absurd precision. But if you ask for a human-scale visual model that preserves every feature without distortion, the answer remains incomplete. This is not because the theory is weak. It is because your inherited intuitions were not built for this layer of reality. That should increase your attention, not reduce it. Because the quantum disturbance does not merely make light weird. It exposes a deeper pattern in physics itself. Nature often refuses to honor the categories that human survival once made sufficient. Solid object, smooth wave, shared now, continuous influence. Those worked on the savannah. They do not survive unmodified in the foundations of the electromagnetic world. And that brings us to the next pressure point. If light is a quantized excitation of a field, then the clean old image of a thing traveling has become even less stable. You have a framework powerful enough to explain threshold energies, interference, and discrete detection. But a new question is waiting inside the success itself, and it is the one the mind cannot stop asking. If light is an excitation of a field, what exactly is propagating, and in what sense does it exist between emission and absorption? The better framework begins with a surrender. You stop asking what light really looks like in the language of ordinary objects, and you begin asking what kind of structure could force all the behaviors we have already seen. Fixed causal speed, no ordinary rest frame, wave interference, discrete detection, threshold energy transfer. The demand is no longer for a comforting picture. It is for one framework strong enough to hold all of those facts at once without cheating. That framework is not a tiny glowing projectile moving through emptiness. It is this. Space-time provides the geometric stage on which causal structure is defined, and the electromagnetic field provides the dynamical structure, whose quantized excitations we call photons. Geometric means having to do with the shape of possible relations in space and time. Dynamical means having to do with change, evolution, and interaction. Put plainly, relativity tells you the rules of the arena, and quantum field theory tells you what kind of disturbance light is within that arena. That combination already clears away several false problems. It explains why light's speed is not just a measured accident. Massless excitations of the electromagnetic field propagate at the invariant speed built into space-time structure. Invariant means unchanged across inertial frames, across observers moving steadily relative to one another. It explains why the bullet picture failed. A photon is not a tiny marble with a hidden clock and a little cabin of inner experience. It explains why the pure classical wave picture failed. Energy exchange with matter occurs in quantized packets, not in endlessly divisible dribbles. So the contradictions were not all real contradictions. Some were collisions between deeper physics and shallow language. The best metaphor I know is legal music. Imagine a violin string stretched inside a courtroom, whose architecture fixes exactly which resonances are allowed. The courtroom is space-time. It determines the lawful relations of distance, duration, and causal reach. The string is the electromagnetic field, present not as a material rope in space, but as a structured possibility of excitation. A photon is not a bead sliding along the string, it is one allowed note of that system, one quantized excitation, one lawful event in a deeper order. The metaphor is imperfect, but it does crucial work. It keeps you from imagining light as either a pellet or a puddle, and it resolves a major anomaly we have been carrying since the beginning. We kept stumbling over the question of how light can cross space without fitting the ordinary idea of a traveler. In this framework, the crossing is not best imagined as a miniature adventurer enduring a private voyage. It is the propagation of a field excitation along the causal structure permitted by space-time. That is why the question, what was the photon experiencing during the trip, keeps failing to cash out cleanly. Still, this is where honesty matters more than elegance. The framework is powerful. It is predictive. It is not conceptually cozy. Walk into a dark room and tap your phone screen awake. A cold rectangle lights your hand, the edge of a table, the skin of your wrist. according to our best description. What is happening is not absurd in the mathematical sense at all. Quantized excitations of the electromagnetic field are being emitted, propagating along spacetime's causal structure, and interacting with charged matter in your retina. Every part of that sentence is precise. Every part earns its keep. And yet the mind still asks its old forbidden question. Yes, but what is actually there between source and detection? This is where the explanation becomes incomplete in a very specific way. Not false, not weak. Incomplete in the sense that it gives you a formal structure more satisfying to mathematics than to intuition. Different interpretations of quantum mechanics describe that in different ways, and this remains debated at the philosophical level even when the predictive core is shared. The calculations converge, the pictures do not. That gap is not a crack in the science, it is a crack in us, because by now the outline is strong. Light is not a fast object in the everyday sense. It is a quantized excitation of a field, and that field operates within a spacetime whose geometry gives light its special causal status. That is the best usable synthesis we have. It is better than bullets, better than vague wave talk, better than schoolbook awe, and still it leaves a residue that will not dissolve. Why does our best description become strongest precisely where our intuition becomes weakest? The ordinary rule is almost embarrassingly simple. If something exists, you should be able to imagine where it is, what state it is in, and how it changes between one event and the next. Common sense does not demand advanced mathematics. It only demands a home address for reality. A stone is here, then there, a spark appears, then fades, a bird leaves the branch, crosses the yard, lands on the fence. The photon keeps refusing to provide that address. By now we have a stronger framework than we began with. Light is not a tiny bullet. It is not merely a classical wave in the old mechanical sense. It is a quantized excitation of the electromagnetic field, propagating along the causal structure of space-time. That sentence is precise enough for modern physics to build lasers, fiber optics, quantum experiments, astronomical instruments, and entire technological civilizations. And still the mind remains unsatisfied. Because the mind keeps asking the primitive question that physics never fully abolishes. Yes, but what is the photon doing in between? Take a concrete scene. A single photon is emitted from an atom in a distant star. Much later, after crossing interstellar space, it contributes to a click in a telescope detector on Earth. Emission here, detection there. The beginning and end are physically meaningful. They are recordable. They can enter equations, instruments, and laboratory statistics. But the intuitive demand for a middle picture remains difficult to honor without distortion. If this were an ordinary object, the story would be easy. You would assign it a path, an evolving state, perhaps a rotation, perhaps some minor environmental disturbances, and then arrival. If it were a perfectly normal wave, you would imagine a continuous distributed ripple passing through a medium. But the photon lives in neither of those houses without breaking furniture. That is why common sense keeps failing. Consider the rest frame problem one more time, but now at full depth. For ordinary massive things, there exists in principle a frame of reference in which the object is at rest. Rest frame just means the viewpoint from which the object is stationary. In that frame you can define its internal clock, its local duration, its state evolution in the most comfortable way. A photon offers no such refuge. The theory does not give you a valid ordinary rest frame for light. That is already enough to make visualization unstable. Then comes localization. Localization means specifying where something is in space. You can localize a tennis ball fairly sharply. You can localize a dust mote with effort. But a photon, as described in quantum theory, is not always a neat bead occupying a sharply bounded little parcel the way intuition wants. Depending on the situation, the most faithful description may involve a wave function, a field mode, or an interaction amplitude rather than a tiny traveling point object. A wave function is a mathematical object encoding the probabilities or amplitudes associated with possible outcomes. An amplitude is a quantity that helps determine the likelihood of physical results when quantum processes interfere. You can calculate, you can predict, but you cannot always translate those objects into a single trustworthy movie. I need to say this directly. We do not know how to convert every successful mathematical description of a photon into one universally accepted intuitive picture. This remains debated at the level of interpretation. Copenhagen-style views, many-world-style views, relational views, pilot wave approaches. These differ in what they think the formalism is telling us about reality. The experiments constrain them brutally. The ontology remains unsettled. Ontology here just means what the world is like, not just what numbers come out. That should not sound like weakness. It should sound like contact with the edge. Think of a legal document carried through a city by many messengers, copied at checkpoints, encoded in secure channels, verified by stamps, and finally enacted in court. Every stage is rigorously governed, every handoff is recorded, the law functions, the outcome is real. But if you ask where, in one simple material sense, the authority itself was living during the whole process, the answer gets diffuse, not mystical, distributed, structured by roles and rules more than by one portable lump of substance. A photon feels like that to common sense. Real enough to trigger events, sharp enough to exchange energy in packets, lawful enough to calculate precisely, and yet strangely homeless inside the old demand for a single classical picture. That homelessness grows when you catalog the pressure points. No ordinary rest frame. Consequence: the traveler model cannot fully stabilize. Discrete detection events. Consequence: pure continuous wave imagery fails. Interference structure. Consequence: pure pellet imagery fails. Field-based description. Consequence: where is it exactly? May be the wrong primary question. Interpretive plurality in quantum theory. Consequence: predictive success does not force one final mental picture. This is why I resist the lazy comfort of saying light is both a wave and a particle, and leaving it there. That phrase helps beginners avoid worse mistakes, but it can also freeze curiosity too early. The real lesson is more severe. Common sense was designed for medium-sized objects moving slowly through stable environments. It was never meant to house field quantization, invariant causal structure, and interpretation-sensitive formalism in one seamless image, and yet physics keeps working. That is the disturbing part. You can build photomultipliers, semiconductors, interferomotors, and quantum communication systems. You can predict scattering cross-sections and spectral lines with astonishing accuracy. A cross-section is a measure of how likely particles or excitations are to interact in a given way. You can model emission, absorption, reflection, refraction, diffraction. Diffraction just means the spreading and bending behavior waves exhibit around openings and obstacles. The world answers to the equations even while the mind keeps failing to turn them into one domesticated picture, so the question becomes sharper, not softer. The problem is no longer whether we understand nothing. We understand too much to pretend the old pictures were adequate. The problem is that understanding at this level ceases to feel like possession. It starts to feel like disciplined contact with something that exceeds the categories that made human life navigable. And that is why this should matter to you the next time a detector clicks. A laser scans a barcode. A fiber cable carries a message, or a star becomes visible over a roofline. You are not merely encountering a well-behaved little object. You are depending on a phenomenon that modern theory handles with surgical precision and common sense still cannot fully house, which leaves the deeper wound exposed. If we can calculate light better than almost anything else in science, why does it still evade a stable mental picture? The ordinary rule is intimate. Perception feels immediate because the medium disappears. You look at a face, a doorway, a tree line at dusk, and your attention goes straight to the thing seen. The carrier fades out. Vision feels like contact, not mediation. The world presents itself, and you accept the presentation as direct. Light ruins that innocence the moment you think too hard. Stand in your kitchen before sunrise. The window is still dark. Then the first weak gray arrives. Almost nothing, just enough to separate the sink from the wall and the edge of the mug from the counter. A few minutes later, stainless steel catches a pale line. Then the room opens all at once. Shapes step forward. Surfaces announce themselves. Your morning begins because space-time, fields, quantized excitations, and biological detection have entered into a temporary alliance so successful that it masquerades as simplicity. You call that seeing. From first principles, the chain is not mystical at all. Light is emitted or reflected. It propagates according to the causal and field structure we have been describing. It strikes molecules in your retina. Retinal molecules are light-sensitive chemicals in the back of your eye. Their configuration changes. That triggers electrical signals. Those signals are processed by layered neural circuits until a world appears to you, coherent, stable, external, obvious. Obvious is the most misleading word in the whole sequence, because none of those steps licenses the old fantasy that you are simply receiving little luminous objects in the everyday sense. You are depending on an interaction chain whose carrier defies ordinary rest frame intuition, resists clean classical visualization, and is best described through a mathematical structure stronger than common sense. Your most continuous access to reality is mediated by something you still cannot picture without compromise. That should change the emotional weight of ordinary scenes. A child's face in afternoon light. Consequence: Intimacy is riding on field theory. A traffic signal turning green in rain. Consequence, action depends on a quantized disturbance in space-time. A message glowing on your phone at 2 a.m. Consequence, your private life now rests on a causal architecture older than humanity. A galaxy visible as a faint blur through a telescope. Consequence, you are looking at ancient interactions carried by a phenomenon still resistant to stable imagination. This is where the scientific story folds back into human scale. You do not merely study light in laboratories. You borrow it every second to build the visible world. Memory leans on it. Orientation leans on it. Recognition, beauty, danger, distance, tenderness, writing, screen, shadow, sky, all of it arrives through a messenger, whose deepest description remains partly formal and partly unsettling. I find that beautiful in a way that still feels slightly violent. Because the mind wants the tools of survival to be simpler than the structure of the universe. It wants seeing to be a clean transaction. It wants a world where the thing that makes reality visible is itself easy to picture. Instead, nature gives you something harsher and more dignified. The visible world is not handed to you by a transparent mechanism. It is assembled through a phenomenon that has already broken your intuitions about motion, duration, locality, continuity, and objecthood. And yet the assembly works almost perfectly. That is the part I do not think we should rush past. We do not know how to translate the full success of our theories into one final human image that feels native to the nervous system. That remains debated. That remains incomplete. But the incompleteness does not block your life. It saturates it. You open the curtains anyway. You read anyway. You recognize the people you love anyway. The mystery is not elsewhere. It is doing utility work inside every ordinary morning. The extended metaphor that keeps returning to me is language itself. You hear a sentence and leap directly to meaning. You do not usually dwell on air pressure, vocal folds, grammar, syntax, memory, inference, and cultural history all cooperating in real time. Communication works so well that the machinery vanishes. Vision does the same thing, but with an even deeper insult to intuition. You receive a world and forget the carrier. You inherit clarity and ignore the price. Light becomes invisible as a problem precisely because it succeeds so completely as a condition. That is why this belongs in your daily life, not just in physics. Tonight, when a lamp turns on and a wall becomes visible, you may feel a faint after-image of this entire argument, not in equations, in mood, in a brief hesitation before familiarity seals the room again. The cup on the table, the grain in the wood, the reflection in the glass, the shadow under your hand, none of it is merely there in the simple way it pretends to be. It is arriving through a lawful mystery, and that realization should not close the subject. It should open it wider, because once you accept that vision itself depends on something you cannot fully imagine, the final step becomes unavoidable. The world has not become less real. It has become less finished. What does it do to an ordinary day when you realize that visibility itself rests on a conceptual mystery? Seeing feels gentle because it hides the force of what had to be sacrificed to make it possible. A room brightens. A face emerges from shadow. The rim of a glass catches the window and throws a pale shape onto the table. Nothing in that scene announces theoretical violence. Nothing tells you that to make such simplicity possible, physics had to tear apart older intuitions about motion, rest, duration, simultaneity, continuity, and even what counts as a thing. And yet that is exactly what happened. The closing temptation here is reassurance. To say that science solved the mystery, or nearly solved it, or at least reduced it to respectable language, I do not think that is honest. Science did something more impressive and less emotionally comfortable. It built a structure strong enough to predict light with astonishing precision while leaving the human imagination partially behind. We know how to compute, we know how to engineer, we know how to detect, redirect, amplify, quantize, and exploit, but we do not possess one final picture that makes the whole thing feel native to thought. That is not an embarrassment. It is a clue. Because it suggests that reality is not obliged to become picturable at the scale of human instinct. The nervous system evolved to catch prey, avoid edges, recognize faces, and move through warm matter at low speeds. It did not evolve to host invariant causal structure, quantized field excitations, vanishing proper time, or interpretation-sensitive ontologies. Ontology here just means what really exists, not just what our equations happen to output. The fact that your deepest scientific descriptions outrun your inherited imagination may be exactly what a mature contact with the universe is supposed to feel like. Not mastery, contact. The metaphor I keep ending with is stained glass in a cathedral you never noticed was there. In daylight, you look through it and call the world visible. You think the glass is serving you transparently. Then one day the sun shifts, and the window stops being invisible. You notice the lead lines, the colored fractures, the way the whole building has been filtering reality long before you learn to name it. Light feels like that now, not a simple carrier, a structural condition, a filter, a frontier, a disciplined mystery, masquerading as familiarity. And once that shift happens, ordinary life will not feel entirely ordinary again. You will look at a sunlit wall, and the phrase "light is moving" will feel incomplete. You will watch dust in a late afternoon beam, and the old bullet picture will seem too crude to survive the sight. You will see a star above a roofline, and feel, perhaps for a second, that visibility is the delayed arrival of a problem deeper than astronomy. You will wake in darkness, touch your phone, and watch your hand appear in cold blue light, and that small act may carry more metaphysical weight than it used to. That is the behavioral anchor I care about. Not memorizing a theory, not reciting that photons are quanta of the electromagnetic field. True as that is, it is not the real end of the experience. The real end is perceptual. A faint hesitation enters your seeing. Familiar things remain familiar, but they lose the right to be simple. That is a gain, because a world that becomes stranger without becoming less real is a better world to inhabit. It asks more of you. It rewards a higher form of attention. It replaces the cheap satisfaction of closure with something rarer, a stable intimacy with the unfinished. You do not leave with the comfort that the puzzle has disappeared. You leave with the stronger knowledge that the puzzle is built into the conditions of appearance themselves. Light is not just one more object in the universe. It is part of the reason the universe can become available to minds like yours at all. And that is why this subject never really ends at physics. It bends toward philosophy, whether you want it to or not. If the medium of visibility already escapes common sense, then common sense was never the final court of appeal. If the most precisely measured things can still exceed clean imagination, then explanation and picture were never the same achievement. If what makes the world available is itself only partially available to intuition, then perhaps reality is not hiding from you in distant black holes or unreachable epochs. Perhaps it has been arriving at your eyes all along. So the quiet violence of seeing is this. Every visible thing feels immediate, while the condition making immediacy possible remains conceptually unresolved. We measure it almost perfectly. We depend on it constantly. We still do not finish it in thought. And perhaps that is the final reality check Feynman would have respected most. The deepest truths may not be the ones hidden from view. They may be the ones flooding the room, crossing your face, illuminating your hands, and still refusing with perfect calm to become small enough for common sense.